make a double bond. And then once we have that double bond, we can get rid of a carbon. We can split it by doing ozonolysis. Or if you're really living wild, you could do KMNO, some really hot concentrated KMNO4. And from there, well, we could just do reductive amination. Right? We have a ketone. We can do that without too much problem. That's a nice reaction. Okay. This is a nice way of doing it, actually. I totally didn't have this in mind. Um, I really like this is a good method. I like this. Uh, I should say there. The other method that's presented here in the solution is like totally crazy. I have no clue what they're trying to do, so I won't even put it up. It's way more confusing than this. This is a lot clearer. Um, this other method that I have is like using a Hoffman elimination, and it does some crazy stuff. So we're not gonna worry about it too much. I also don't think it's right because the first few steps are kind of all over the place. All right, here we go. How about we do the last one, and that'll be it. That'll be the last organic chemistry workshop problem you'll ever do. One of the last organic chemistry problems ever that you'll do. Hopefully. Maybe not. Maybe you'll be stuck doing more organic chemistry, but hopefully if that's the case, then you actually like organic chemistry. But here we go. All right, we've got benzene and we're trying to go up to here. Okay, this one doesn't look as bad, hopefully. We hope. Right. Uh, so here we want to, let's see. If we go retrosynthetically, well, these two are para to each other, so we'd have to add this N first. Okay? So let's say that we had something like this, and then uh, we went up by H2SO4 HNO3. Right, that's the conditions, okay? And then, well, from here we can go H2SO4 HNO3, right? We're trying to get a nitrogen onto the ring. So, okay, there's NO2, and you could do your usual reduction there. So, iron and HCl. NH2. And, all right, well, that's really nice, cool, we've got somewhere. But this becomes challenging at this point because we need to go from this NH2 and methylate it twice. So, how can we do that? Maybe I should ask, is there a problem with it if we do this? Will we get the dimethylated product or will we get something else? Thoughts?
Can methyl iodide add to the ring as a nucleophile, or well, I guess that's impossible here because you have the donating group, but I think it's fine. I don't know.
Okay. So what I'm thinking here is, well, so methyl iodide is really good for adding onto a group. It's super good for electrophilic aromatic substitution, right? But there's no Lewis acid. So, okay, that won't work out that well. All right, so this won't add onto the ring. But the thing is, every time you add one of these methyls onto the nitrogen, it gets more nucleophilic. So you wouldn't form the dimethylated product. You would really form a bunch of this with the trimethyl. That's a positive charge. And then you'd form some amount of, you know, whatever's left over. So it's not going to work out too well. Okay. So this method was, it was so good, it was so close until the very end. So it's not going to work. Okay, so well, we have to go back. We have to start thinking about it again. Um, but I promise this problem isn't very long. It's just like an unexpected thing, an unexpected way of doing it. So okay, how else can we make this final product? Well, what if we're really crazy and we say, okay, there is an NO2 on the ring, and instead we want to attach this whole thing, this whole nitrogen with two methyls on it. Well, we have a way of doing it. Okay, so what we can do is add a whole bunch of this dimethylamine, and you can heat it a whole bunch and do nucleophilic aromatic substitution, right? This NO2 is withdrawing, so this will happen. This reaction can happen. It'll work. Okay, so that would be a good way of sticking this whole thing on there at the end. And from there, well, we know how to get this, right? The chlorine is orthopara directing. So how about we chlorinate aluminum trichloride, Cl. Okay, and then okay, we can put the nitro group on, and then we can stick on that for our final product. Okay, that is it. That is our final problem for all of Organic Chemistry Workshop. Um, we are all done completely. So that is it. I should say, if you have questions, let me know. I'll upload everything and all that. Thank you for those of you that keep, bugging me and telling me to upload things. It's helpful. I don't mind. It's good. I will try to upload this fairly soon and put everything up. I'll also send out a sign-in sheet. I always forget. I keep forgetting this thing, but I'll send it out. And I guess besides that, well, yeah, thanks. I've had a very good 2 semesters, and well, 1 semester and 2 semesters with a lot of you. It's been good to keep up with my organic chemistry as well. I've really enjoyed getting to know a lot of you. So enjoy, the last week of class, or really finals, I guess. Enjoy the end of organic chemistry, and I'm sure I will see many of you around. But I saved this. Okay, I will end the call as usual. So goodbye, everybody. Stop recording. Yeah.